With 99904W and New Palestine Robotics, and today I'll be showing you how to use our simulation programming. To start, download the file or follow the link attached to this video. The file is not here. Downloads and whoosh simulation programming. Then just drop it into snap.berkeley.edu, and it might take a second to load in. And this program will have everything you're going to need for our simulation programming. So you don't need to use any other website or any other application like VS Code to run it. This should be everything you need. Just an overview for our program. We calculate the best route using by solving a VRP, which is the same thing that like UPS and FedEx do. And then we input that route into a route designer to get a program as the output. Just to preface this program has been tuned to the specifications of our robot, and you may need to adjust accordingly. I'll show you more about that later. What I'm showing you is our hand routing block. So you can, with this block, you can input a starting position and a starting direction, and all you have to do is enter what ring or what MOGO you'd like to go to, and it will find the route for you. So if I'm able to drag this over, you can see a little better. So over here we're saying when the 1 key is pressed, it'll initialize it, and this route by hand block is the important block over here. So when I press 1, just typing, it will go up to this corner, and it will, I can input, like I want to go to ring 1 right now. It'll go to ring 1. I want to go to the MOGO, first MOGO. I'll go to the first MOGO. I want to go to this ring. And I can do this however long I want. And when I'm done, all I have to do is I have to input D for done, and it will animate the route for me. With this block, it will ensure that the back of the robot is on a flat edge of the mobile goal, so that you're not getting uneven clamping or something along those lines. So to start, if you want to use this block and you want to start in a different spot, this first parameter right here is going to be your X position. So 123 for us is where the back of our robot is, right on that white line. That's starting as far forward as you can. In the route by hand block, it's going to be your Y position. So if you want to make this, say, 40, then it'll just move the robot down lower. The only reason I had it at a specific Y coordinate was because setting up the robot from the simulation is the hardest part about using this program. And if you want to go straight at a ring, it's easiest to just go straight to the Y level and not have to be tilted. It also makes your setup more consistent. The route finder is a little bit more complicated than the first one. For this block, we give parameters of the starting location, the starting angle, and the first ring or the first mobile goal we would like to go to. This helps a lot, especially this year, with just going straight to the thing. So if you want a ring rush or a MOGO rush, you'd input like 2 or 3 into that location, and you're going to go straight for that. You can change how long it takes to formulate a route by changing the runtime over here. So right now it's set to 10, so this program will simulate through routes for 10 seconds. You can decide how long you would like to make that based off of the cycles. So if you would like to see any of the variables that are in here, you can just click check on this, and it will pop up right here. So when I click this, oops, typing again. I click this, it will put a whoosh logo over the objects that's going to, and the cycles, as you can see, are counting up. And at the end of 10 seconds, it'll display the best route on the right, and the cycles are there if you click the check mark. So the way that it actually finds the best route is by solving something called a VRP, or a vehicle routing problem. This is the same thing that UPS or FedEx do when they're delivering packages. So how it works is, for us at least, is it calculates the amount of distance the robot has to move and the degrees the robot has to turn. And they add these together right here, and that's how we get our total cost. And we can compare routes to each other based off of the total cost of the route. So for this route, we set that if it was under 2,000, we declared that it was a good route. And it was a route that we thought was good enough for us. That doesn't mean it was the best one, but that was our cap. So you can change that accordingly, but if you'd like to change this, say we want to write a longer route, then up the number, and you have to click apply, otherwise it won't actually affect the block and nothing will happen. That goes for the same things when you're inputting your locations up here. If I want, say, less locations, I can drop a few things off, and I can say this, and if I just run this again, it's going to go through all of the same locations. So it didn't actually update. I have to click R to stop it and reset, and then I have to actually apply it. OK does the same thing, it just closes the editor tab, and then I click 2, and it will run the same thing. I'm not sure if it actually updated that time. Oh yes, it did. So it went for just the things that I updated it to in the locations. And this shows in the upper right hand corner, and you can take those routing things, and when you press 1, you go back to 1. Oops, I'm on the wrong starting Y. We want 115.3627. In the upper right hand corner, we can simply press 1 to go into the manual routing, and we can input these as they appear in the right hand corner. And there we go. And I say done. It'll animate it for me. And then after that, if I want to get this program, I want to be able to input it into my VS Code or into my way to download it to the robot. All I have to do is go over here to the Variables tab and click on the best route will be the same thing as in the right hand corner. We want to see the best output. So if I click this, it will right here give me everything I need. So it'll start the void, and it'll give me all of the drive distances, I believe down to 15 decimal places. So a lot more accuracy than most PIDs have, and all of the turn angles, and you can copy paste this directly from this. If you right click on this and you click export, it'll give you a CSV file. Then once you have the CSV file, all of these lines will be in one line, and you can copy paste them straight into your program. The only thing is it will all be in one line, so you have to click enter a few times. That's somewhat annoying, but it's not bad considering you already have an autonomous written. And that's about all for what we have right now. But in the future, we're going to make a few changes with this, and we're going to come out with a few more releases. So some of the things we might add are making the cost cap, like for the total cost, might convert that into time and opposed to kind of abstract number. we might add swings. So instead of just driving straight and turning to a certain angle, being able to combine that into one function and prevent some collisions. So sometimes if I say I want to go, say I want to go from 1, and I want to go to this MOGO down here, it just drove through the hang structure. So avoiding that, and if anybody has any suggestions, it'd be greatly appreciated. Would consider it for sure. And that's about all. Thank you. This that I meant to show you how to set this up for your own robot, and I forgot to do so, so we're gonna do that right now. So the first thing is the robot, the actual robot sprite. For the animation, you measure from the front of your intake to the back of your clamp, and that distance in inches, you convert that into pixels. So you multiply it. If it's our robot was 13 by 14.5. So multiply it both by 2 to get to the whole numbers, and we got 26 and 29. So we took a screenshot that was 26 by 29 pixels. It's really easy when you're at least on a Mac. You can show you how pixel count, and you can size it. I believe we're sized at 75%. It might be 25 though. I want to check on that. You can also change the distance with how far or how close you want to be to the MOGOs and the rings. So to do that, it's just right over here, distance from the MOGO, distance from ring. So right now, distance from MOGO is set to -16. If you want to back further into it, I believe you raise the number, so going closer to 0, that will be further into the MOGO. And the thing with the distance from ring, so the same thing, you increase, or sorry, no, it's opposite. So if you decrease this, that'll be the closer you get to the ring. Those are a few things you can change with it. If you want to change how the output gets delivered, you can come over here, and in C++ writing, if you click edit on this, all of these are how it's being outputted. So I've made this work with my program. I have a public GitHub, so if somebody wants to use that, you can download that and convert it into that, but that's a lot of work. So if you want to use what you already have, all you have to do is change this. So I'm not 100% familiar. I don't use lemlib or anything like that. The values that are actually important are already calculated, and everything else is added to it. So this distance time calculator, it will time optimize it for you, and that's your time in seconds. And this number here with this calculation, that is your distance in inches. And for turning, it is down here. So it will be absolute turning. So if you are at, say you're starting at 0, then you have to, it'll go through and it'll say like -470 if you're turning to the left 470 degrees. And all of the mobile goals have different things because they have to ensure that they are on the correct faces. That shouldn't be something you have to mess with, just changing the characters here. And if you have other parameters, you might want to add those as well. And you can feel free to add whatever you'd like to this program, and I will try my best to get it out there if you wish to do so.